Good day everyone. My name is Atharva Joshi and I am delighted to be here today alongside my fellow group members to present our PowerPoint presentation. Our project focuses on simulating a washing machine interface using picsimlab. It is a microcontroller based platform. Before delving into the details of our project, I would like to take a moment to reflect on the invaluable experiences gained during the past few months of our internship. Throughout this period, our mentors provided unwavering support, guiding us in acquiring new skills and assisting us at every step of the journey towards developing this project. Now I will provide a brief overview of the subjects we covered during our internship. We started with C programming languages, where we understood data types in C, which told us that which data can be stored in which type of variable. Then we explored conditional constructs like if-else statements, where we get to know that which code or block can be executed depending on different conditions. Then we later learned about control flow statements like break and continue. Then we gain proficiency in various operators like logical operator, pre and post, increment decrement operator, relational operator, assignment operator, bitwise, size of, and then ternary operator. We also gained awareness of overflow and underflow issues. Later, we gained proficiency in arrays and pointers, which are crucial for efficient memory management and data manipulation. Lastly, we also gained our skills in strings and functions, which are fundamental components in C programming for handling text data and organizing code into reusable blocks. Next topic we learned was pre-processing. Pre-processing is basically the initial step in compilation process. This involves grasping significance of header files and defining them in our program. Basically in C program there are header files like stdio.h, which helps us in performing input and output operations. Then there is string.h, which helps us utilizing string functions. Then we learned about macros, understood its syntax and how the code is expanded in macro objects. Then we gain proficiency in macro arguments, which helps us in creating more flexible and efficient code structure. By understanding pre-processing, it allowed us to gain necessary skills to organize our code before we proceed to further compilation stages. Next topic we learned was embedded system. Embedded system is a specialized computer system which is designed to perform specific tasks within larger system or product. Basically, unlike computer or our mobiles, which are multiple software which perform many set of functions, embedded systems are specifically designed to perform certain functions, specific functions. Like in air conditioner, it is used to change temperature. In washing machine, it helps us in washing clothes. Basically like that. They are often used in consumer electronics, industrial machines, automotive systems, medical care, and more. Embedded system can be defined as combination of hardware and software which is intended to do a specific task. These are some examples of devices which have embedded system like traffic management, security system, printer, oven, ultrasound machine, audio system, television, fax machine. More examples are refrigerators, air conditioners, and washing machines. Common design metrics which should be considered during selecting an embedded system are as following. First is performance, how quickly and efficiently the system can execute a task. A good embedded system can perform the task in less time. Power consumption, the amount of power it consumes during the operation. A good embedded system will require less power to perform the same operation compared to other average embedded system. Size and form factor. Embedded systems should be small in size so it can be properly used inside the applications. Cost. The cost of design, development and production of embedded systems should be low. Security. Data is basically very important, so embedded systems should be able to protect against unauthorized access and data breaches. So embedded system should also be reliable so it can perform its specific task under different conditions. Scalability. Embedded system should be accommodate changes and upgrades in different times. Real-time aspects in embedded system are as follows. First is hard real-time, second is soft real-time, and third is firm real-time. In hard real-time system, task must be completed within strict and deterministic time bound. If we miss a deadline in hard real-time system, it can lead to catastrophic consequences such as system failure or safety hazards. Soft real-time also has time constraints, but they are less stringent compared to real-time system. When meeting deadline is important in this system, Sometimes deadline missing may be tolerable, but by missing deadline, it can lead affect the performance or user experience. Firm real-time systems, they lie between hard and soft real-time systems. In firm real-time system, meeting deadlines is critical and missing deadlines is generally not acceptable. But if the deadline is missed, it is tolerated as it does not affect the system's overall functionality. Microcontrollers is a compact integrated circuit which is designed to execute specific tasks within the embedded system. It consists of central processing unit, that is CPU, memory which is both volatile RAM and non-volatile ROM, or it can be called flash memory. It has input-output peripherals and various interfaces which are all integrated on a single chip. Microcontrollers are commonly used in embedded systems where they control various function and process. They are found in many wide range of applications like consumer electronics, automotive system, industrial automation, medical devices and more. Key feature of microcontroller is its small size, low power consumption and its ability to operate in real-time environment. They are programmed to perform specific tasks using software written in high-level programming languages like C, C++, and their flexibility allows us for customization and adaptation to different applications. Now, how to choose a microcontroller. These are the following factors which helps us in deciding how to choose a microcontroller. First is application. Determine specific need of our project. Then performance. Microcontroller that we select should be able to handle the workload efficiently of our project. Price. It should be within our budget. Otherwise, it can affect the overall project planning. Availability. The microcontroller we want should be available in the market. Availability of tools. The tools which we use along with microcontroller should be available for adequate development. Special capabilities. Assess if microcontroller meets any unique requirement for our project. Communication protocol. Communication protocol is set of rules and conventions which governs how a data is transmitted and received between devices or system in a network. It defines the format, timing, sequencing, and error checking procedures which are used during communication to ensure that the information is accurate and reliable. Communication protocols depend on many factors such as type of network, transmission medium, and specific requirement. Some examples of communication protocol are Ethernet, Wi-Fi, Bluetooth, TCP/IP, USB, etc.
I'm Pratik Shinde. I'm going to tell you about problem statement and functional requirements of our project. So this project simulates a washing machine in picsimlab and replicates real-world functional functions visually. It explores washing machine components, cycles, and operations considering factors like fabric type, load size, and water level. Through simulation, it provides insights to washing machine operations. Control system design and intelligence appearance simulation, enhancing understanding of laundry automation. There are three major tools which we are going to use in this project. First is MPLab X IDE, which is a development environment. This tool is used to program the microcontroller, and the second tool is MPLab XC8 compiler. The program which we did in IDE, that XC8 compiler compiles that program to run in microcontroller. picsimlab simulator is a simulating tool which allows us to simulate with any kind of microprocessor controller without having it physically. So it gives us access to virtual microcontrollers. Functional requirements of washing machine. So there are four switches: power on, pause, stop, navigation, and door status. First, with power on switch, the signal goes to microcontroller after switch number 5, which is power on switch is pressed, and it gives signal to buzzer that we are powering on the washing machine. Second switch is switch number 6, which is pause stop switch, which gives signal and microcontroller pause or stop the washing machine. Switch number 4 is used to navigate the uh, many other options which we are having, like our daily daily and daily heavy delicate white stains. To navigate these options, we are using switch number 4. Switch number 1 is used for door status. Door is closed or open, that goes on the CLCD display with the switch number 1. So first, power on screen functional requirement. We will give its input from switch number 5, and it wait until switch number 5 press, then turn on the washing machine. It gives us output as displaying press power key 5 to power on the washing machine on up on our CLCD display. And second screen is washing program screen, which takes input as switch number 4 and 5, and its process is washing program selection and navigation. It gives us output as displaying the washing program menu, which is daily, heavy, delicate, white, stain, wash, eco cotton, woolens, bedsheet, range high, dry only, wash only, aqua store. Our washing programs are daily, heavy, delicate. Switch number 4 is used to navigate, or we can say scroll the menu. Our third screen is water level screen, which takes input from switch number 4. Its process is selecting and navigating water level options, and gives its output as displaying the water level menu. Our menu gives us 5 options, which are auto, low, medium, high, and max. Water level medium use switch number 4 to scroll between available options. A long press of switch number 4 will select the highlighted option with start, then transition to the start and stop screen. Start screen takes input from switch number 5 and switch number 6. Process to initiate the selected option, and gives us output as displaying the following options, which are press switch 5 to start, switch 6 to stop. Upon pressing switch 5, start the machine and display the selected function and its corresponding time. This transition to the function screen. If switch 6 is pressed, return to washing machine program screen. Function screen. That screen takes input from switch number 1, switch number 5, and switch number 6. This process is display the ongoing functions, and left time means it will show us on screen that which function is running and how much time is left. As output, it displays the current function and remaining time on the CLD. Its function is wash, rinse, and spin. Time determined by the washing program and water level. If switch 5 is pressed, start the washing machine. If switch 6 is pressed, pause the washing machine. If switch 1 is pressed, activate the button and display door opens to indicate the door status. Compilation screen. Compilation screen basically displays the notification program completed, remove loss on the CLTD, which tells us that our clothes are fully washed and we have to get them out of the machine.
I am Ajit Taram. Now let's head toward the working of your project. Now let's open MPLab XID. Here we have developed a washing machine program. This is main C file which is responsible for working of our project program. This is main header file. This is digital keypad header file. This is display header file. This is responsible for time. This is display C files. This is digital keypad C files, and this is timer C files. Now let's clear and build our program. Build is successful. Now load our program in picsimlab. Here our microcontroller is PCI 16F877A. Now let's reload last. Or let's load new hex file. Here is hex file. It has been loaded. Now the display is showing press P5 to power on the washing machine. Here is P5. Now it's showing a navigation menu. Here are various washing programs according to cloth types. If it's daily, heavy, delicate, white, chain wash, eco cotton, woolen, bed sheets, rinse plus dry, dry only, wash only, aqua store. Now let's select daily. Now our next menu is water level. Here we have to select water level according to our clothes. This menu product with 5 options: auto, low, medium, high, max. Let's select auto. Now we have reached our next function. Switch 5 to start or switch 6 to stop. If we press 5, our program will start, or if we select switch 6, our program will stop. Now let's select switch 6, it will stop. Now we are again return to the watching program. Now again, let's select same options. Sorry. We have to wait for few seconds, then and only our option will be selected. Yeah. Then our next one is water level. Here is auto. Then switch 5 to start. Now our program has started here. Our first function is wash. Here we can start or pause the program. Here, if you want to pause, it will pause. And if you want to start, we have to press page 5. It will again start. Here our pen is rotating. And if we want to remove cloths, we can pause our program here. It will pause. And those settings will be open. Please close. Now it's rinsing. Then it's spinning. Here our program has been completed. Sorry, due to some problems, any other sound is not recording. Now here our simulation is done. Thank you. Now let's say to a conclusion. Through my internship, I have gained knowledge about embedded, what is importance of embedded. Through the internship, I have learned about simulation from initial power on prompt to program completion notification. Every stage serves a specific purpose. In this project, user can select various options, adjust water levels, receive alerts when cycle is completed. This experience has given me with valuable knowledge, valuable skills, process simulations, which are essential for my future and my mates also. I am again thanking I am again thanking Emergence for providing this opportunity. Thank you.